Okay, so this is an example problem using memory, and these are, I don't have my tablet sitting here, but I'm going to describe these things, and really the learning comes when you understand the code. I mean, it's kind of weird when you see it the first time, but here we go. So since I want to write a assembly language subroutine, it swaps the data in two contiguous memory locations. So that's two memory locations next to each other, and I think I said that wrong anyway, because they're not really contiguous. The issue is that one is going to be a byte and one is going to be a word. Okay, so the notion of switching bytes, swapping bytes in two locations, not a big deal, but switching words is going to require that the hardware step in on this one, and the issue is that the memory it's byte oriented. So when I read a word, the hardware, I'm going to give it one address. The hardware is going to give me essentially the data at four addresses to form the complete word on this thing. And you're going to see that in the code. So the code's not really amazing on this thing. I essentially, you could draw a flow chart, but these are fairly simple. You can do it without the flow chart because it's so simple. But the point being is that you got to look at this code and you got to be very careful with it, and you'll understand what I see when we look at the code. Anyway, the two solutions are following this. So let's do the bottom one first. It's swapping bytes. So what that means is I got to go to memory and get a byte, and then what do? Well, I got to take that byte and write it in the other byte location, but if I do it immediately, it's going to overwrite the byte I'm interested in, the other byte I'm going to swap it with. So the approach on both these problems is to go get the data, and then I have it in a register, and then I can just overwrite the memory data. So I'm gonna read the data, then write it. I'm going to load it. You can see the load byte sitting here, and then I am going to store it. Okay, so I know I'm using X10s here. I told you not to use those, but not a big deal in this one. It could be any register. So X10 was part of the problem. It said it passed an address in there in X10, and that's the address of the first piece of data I want to swap. So here it is. I go get it. Okay, now I go get the other piece of data. I use X10 as the base address once again, but I offset it by 1, and that's essentially offsetting it by 1 byte. And you're going to see this differ in the other problem here. Okay, and then what I'm going to do is I took the data that I grabbed at 1 greater than X10, which is in register X21, and I'm going to store that at the original whatever X10 is pointing at. Okay, and then I'm going to go store the other byte. Okay, so the offset, if you can see the read and the writes, or the load and the stores, are offset by 1 on the second read. And anyway, this is really important because it is byte oriented. So when I'm swapping words, I need to offset that by 4 because it is byte oriented. I got to advance it by 4 addresses, we'll say, which is essentially 4 bytes. So the code's exactly the same. How the code differs is the fact that the offset is different. And if I was swapping halves, this wouldn't be a 4, it would be a 2. Okay, so this is it's a kind of a tricky little problem, but it shows you something very interesting here, and it's certainly something you always should be on the lookout for. And so what I'm going to do says it reads a word of data from memory and then stores the half words in that. There's 2 half words in that word in contiguous memory locations. So the idea is the word I'm going to get lives at X10. Now, so it makes it seem like it's going to read a word from memory, which is super doable, but it's actually a clunky way to do this problem because I have to do a bunch of extra work on this thing. So what I'm going to do is I am going to read a half word and then read another half word, and then essentially I'm going to store those half words as words and use the offset by 4 because I'm storing them as words. So what you're going to see is I'm going to read two half words at a time, and then I'm going to store those whatever I read as words. Okay, so you can see it. I grabbed a half word at this one. I advanced it by 2. Essentially because they're half words. Now I've got the data in X20, X21. I'm just going to arbitrarily store those as words. Okay, because I'm storing as words, the offset is going to be a 4 on this thing. So this one stores it at the original address. Because it's stored as words, I need to offset that by a 4 right there. And that's all I have, folks.